This is Algebra 1, Chapter 2.8, Literal Equations and Dimensional Analysis. So we're going to cover solving for a particular variable and then canceling out units to get something that I like. So first thing we're going to do is solve for a specific variable. Literal equations, guys, are just equations that involve several variables. It could have two or more variables in it. It could have an x and a y, an m and an n, and an x and a y, n, something on those lines. So there really isn't much to it. The biggest rule is what you do to one side, you have to do to the other. That's, if you can remember that, remember those rules, the properties of equality. You add something to the left side, you got to add it to the right side, subtract it, multiply it, divide it, all of that. So remember, we've moved variables already when we had variables on both sides. Now they're just different variables, so they're not like terms necessarily. If they're not like terms, you can't treat them like terms. You can't put them together like terms. So all we have is examples for this because we already know the rules. So we got to solve for a specific variable. I want you to solve 15 equals 3n plus 6p for n. Get n by itself is what I'm saying. I'm saying get n by itself. So if I look at that, n is in the middle. To get n's by itself, I'm going to have to work my order of operations kind of in reverse in a way. That means anything that's not an n goes to the other side. That's my first step. So look at this problem. The only other stuff that's with it, there's a 3 in front, but unfortunately it's attached to n. It's a little harder to break those attachments at first, okay? When you're attached, it's a little harder to break it, right? But when you're not really attached, so sometimes it's easier to get rid of the things that are extra on your side, like extra 6p. How do I get rid of a positive 6p? Not make it a negative. I can't just make it negative, okay? No, I want to subtract it. So yes, the first thing that I should do is subtract 6p. Those are gone. Do you guys notice that 15 and 6p are not like terms? So it's 15 minus 6p is equal to 3n. Now we can break the bonds, get n by itself, and you would say what? Chuck? Divide both sides by 3. Is everybody okay with that? This is no different if I was solving for an x or a y normally. It's just that we have an extra variable in it. So I divide this by 3. Awesome. So I get n equals 15 minus 6p all over 3. What if I said that this is not your best representation of what's going on? This is right, don't get me wrong. There's a more correct answer, or a better answer. Real. You can divide 15 by 3. I need more. And the negative 6. Guys, do you notice that on the left-hand side here now, this is a fraction. It's a fraction that has a denominator of 3. And since there are things on top of my fraction that are added and subtracted, am I allowed to separate those to their own denominator? Because think about how we put fractions together. If you're adding and subtracting fractions, the condition was get a common denominator, and then you can take the numerators and add them or subtract them. We're going to go in the opposite direction now. Now, what I'm going to do is I am going to separate them. It's 15 over 3 minus 6p over 3 is equal to n. Is everybody okay with that? I basically took the numerator tops, gave them their own denominator. Notice it's the same. I didn't change it. But at this point, you now should be able to say, wait a minute, 15 divided by 3? That's a 5. Negative 6p divided by 3? It's a negative 2p equals n. You now solve for n. Guys, can you put n on the other side? Sure, that's not a big deal. But 5 minus 2p is the value of n. Next problem, I want you guys to try this one on your own. See if you guys can use what we just learned. I want you to solve for d on this, where d plus 5c is equal to 3d minus 1. This is no different than we did with our multi-step problems or variables on both sides. What's the first step, guys? Someone other than Chuck. He's already answered too many times today. Kathy. You could subtract 5c from both sides because that is a legal move. I'm actually going to deny that one right now. First of all, maybe I should talk about this a little bit. We're trying to solve for d, which is on both sides. That means I need to get the d's together, so therefore on the same side. Rich? I'm going to subtract a d because I want to move the what? Smaller coefficient. So it's 3d minus d. 2d minus 1. And at this point, I would not move the 5c, but I would then move the negative 1. To move the negative 1, I add 1 to both sides. And so 2d is equal to 5c plus 1. We're not done yet. Yes, we will divide both sides by 2. So d is equal to 5c plus 1 over 2. Now guys, this one we could leave this way, or we could fix it. You can't divide it by 2 and get a nice number, but you can divide 5 by 2 and 1 by 2. So therefore, I will switch this to say that. So d is equal to 5c over 2 plus 1/2. It does work. It's fine. They don't have to be nice numbers, guys. Essentially, both are respectable answers because I can agree 5 is not divisible by 2 necessarily nicely, and 1 divided by 2 is not necessarily nice either. They're not bad fractions or decimals, though, are they? So are there any questions on that? So even if there are variables on both sides, it's the same rules as you did before. Because remember, variables are just like numbers. You can add them, subtract them, or divide them to both sides, or multiply them. It works. Okay? So, what it comes down to is then you end up getting word problems like this. Like, the largest yo-yo in the world is 32.7 feet in circumference. It was launched by crane from the height of 189 feet. The formula for the circumference of a circle is C equals 2 pi r, where C represents the circumference and R represents the radius. Basically, they're going to start to give you formulas, and these formulas need to be rearranged. The reason, guys, we come up with functions and we set them up a certain way, as in I put in x, I get out y, right? There's a lot of times we see that, is because we have a long list of x's that we want to put into this function and change it. Well, in this case, we have circumference equals 2 pi r. And if I had a whole bunch of problems where I gave you a circumference of something and I wanted to find the radius, nobody wants to plug in a number for c and keep dividing by 2 pi every single time reinventing the wheel, as in reformulating it every time. If I was going to have to solve for r, which part A asked me to do a lot of times by giving me a value of C, I'm going to do that algebraically first. So now I have a formula that all I have to do is plug it in and solve it. This is a fairly straightforward one. Others you might have to do a couple other steps to, like our last problem. So here's our formula. I want to rearrange it to solve for r. What do I have to do? Get rid of what? 2 pi. Just get rid of 2 pi. How do I get rid of a 2 times pi times r? Yeah, just divide both sides by 2 pi. Gone. So the radius is equal to the circumference divided by 2 pi. And then, using the information that they give you, can you actually find the radius of this yo-yo? I mean, a circumference of 32.5 feet seems like it's a fairly big yo-yo. But if I give you a radius, you might actually have a better idea on how big this is. Right? So, r equals, and I'm using my formula that I just created. That's the cool thing. What's the circumference?
15. Wait, it's half of the...
No, that's diameter.
Oh.
Circumference would be half of that. Sorry, let me rephrase that.
Radius.
Would be 2 radii is a diameter.
Yeah, so...
Bill?
61.
Did you have your hand up?
No.
Fritz?
Circumference is the perimeter of the circle.
Right? Do we have it? It's the number up top. 32.7 divided by 2 pi. Take your calculator out. Give me 2 decimals on this thing, if it needs to be. What did we end up finding? What's the radius?
51.339.
51? No way.
Yeah.
32.7 divided by 2 pi.
Are we using the pi button or?
Yeah, use your pi button. But guys, it is not 51. Use parentheses, guys. Yep, right now, a lot of you guys are doing 32.7 divided by 2 and then multiplying it by pi. If you're not using parentheses in the denominator, you got the problem wrong. Think of this. What is pi again? 3.14. So it's about 3, give or take, right? What's 2 times 3? 6. What is 32 divided by 6? What's 30 divided by 6? 5. So you know it's probably somewhere around 5, not 50. Use parentheses. Yes, right now you're doing 32.27 divided by 2, and then multiplying it by pi. Put parentheses around the 2 pi. Luke?
I got 5.21.
5.21 feet. Is that better for everyone?
So instead of putting the actual division sign, I put just parentheses.
No. Here, hold on. I'll pause it. So let's think of this. 5.21 feet. That's about 0.2 is 1/5 of a foot. What is 0.21 times 12? 0.21 times 12, guys. You guys get your calculators? Is how much?
2.5.
So 2.5 inches. So I'm guessing there are people in this room that are about 5'2", 5'3".
Yep.
Okay? That yo-yo has a radius that is as tall as you are. That means that this yo-yo has a diameter of what? 10 feet 5 inches, or 2 of you, right? That's how tall it would be. It's about probably as tall as the ceiling in this room. That's why they needed a crane and 189 feet height so that they could watch it bounce back up. Yeah, it'd be kind of cool to watch. There probably is a world record video for this. We should look that up during our time where we might have time. Okay. Here we go, guys. Now we're going to talk about dimensional analysis. Okay. Okay. Guys, this is called dimensional analysis. There's a lot of stuff here. Listen. There's a lot of stuff here. The first two are definitions. The next one is kind of a six-step process that I found of trying to get you to the idea that you're going to cancel your units. Again, this is very largely used in your science classes. Dimensional analysis, guys, is the process of converting one unit to another using conversion factors. So what's a conversion factor? A conversion factor, guys, which we have listed here, is a fraction which equals 1. It takes two equivalent things, like 12 inches equals 1 foot. You guys agree with that? They're equivalent, but they're in different units, okay? And the biggest thing that they actually state in here is that it equals 1. They're different units, either in its numerator or denominator, and that they have, now this is not all the time, but 99% of the time, you will have a 1 as one of the options. 1 foot is equal to 12 inches. 1 mile is equal to 5,280 feet. 1 meter is equal to 100 centimeters, or 1,000 millimeters. Those are all conversion factors, guys, that you can write as a fraction. Now, 5 steps for using dimensional analysis. Guys, basically, you need to change your given into a fraction. The given, guys, might be the fact that it says you need to convert 5 miles per hour to feet per second. You guys probably have done these types of things before. So 5 miles per hour is your first fraction. You got a top and a bottom. Miles on top, hours on the bottom. Okay. Part 2 says you need to write a conversion factor that has the units you wish. So is there a connection between miles and feet? Is there a connection between hours and seconds? So there's going to be ones, guys, where you're going to have to convert the top units to something else and convert the bottom units, the denominator units, into something else at the same time. Here's the thing. We don't do it all at once. We take single steps at a time, converting it as we go. And you may have to convert these into like 4 other units before you get to the one that you want. Okay? And so, we're looking back at 2. It says, after you fill in your units, add the numbers. So once you established it, you might want to go from miles to feet. Then you're like, oh, 1 mile is 5,280 feet. Those types of things. Some of these you guys are just going to have to know. Otherwise, I'll try to give you hints along the way. It says, then, what we're going to do in step 3 is we're going to multiply the given to each one of these conversion factors. And by multiplying them, you will be able to cancel out your units because you'll have miles on top and miles on the bottom. It says in there in step 4, do not cross multiply. These are not solving that way. And then you can change it to a fraction or to a decimal by dividing the very ends of it to get your answer. Guys, you will always end up with answers being in the numerator. This process will always result in the decimal that would be on top always. You can always convert it back to a fraction, which will have the appropriate units. Okay? The first problem, guys, I want you to convert 568 milliliters to liters. So using the steps from before, we're going to set this up as a fraction. And this fraction is 568 milliliters over 1. That's what I have. I need to recognize, guys, that I want to get rid of milliliters. So milliliters needs to go on the bottom. So there's something about milliliters. And here's the cool thing. Can I go directly from milliliters to liters? Is that okay? I think so. I think most of us would know that. So I can actually go from to liters. Does anybody know the conversion factor between liters to milliliters? Rio? Yeah. So there's 1,000 milliliters to 1 liter. Guys, what happens before I even do any multiplication is that milliliters will cancel with milliliters here. My answer will end up in liters because it's the only units left.
We did this last year.
You should have done some of this, yes. Now, what this ends up doing, guys, listen. I have fractions, and how do you multiply fractions? Across. So 568 over 1,000, which equals 0.568 liters, and there's your answer. I want you guys to convert 15 centimeters to kilometers. So, 15 centimeters times, I want to get rid of centimeters, so I definitely put that on the bottom. Now, most of us do not know the conversion from centimeters directly to kilometers. We usually have to take an extra step in here, right? What's the extra step? To meters. And then you got to ask yourself, 1 meter is equal to how many centimeters? 100. Guess what? Our centimeters will now cancel away. I'm left with meters. I don't want meters. I'll cancel that out. But hey, do we know a conversion factor now that can go from meters to kilometers?
Miles.
I don't want to go to miles.
Kilometers.
So do we know this conversion? 1 kilometer is 1,000 meters. And this will allow me to cancel out my meters. So what do we get? 15 times 1 times 1, which is 15. What's 100 times 1,000? It's a 1 followed by 5 zeros? No, yes. And then the answer ends up being kilometers.
0.00.
So point 1, 2, 3, 4, 5. So 1, 2, 3, 1, 5 kilometers. So in this problem, it says a 10K run is 10 kilometers long. Then they also, guys, are giving you the conversion factor. That if 1 meter is 1,094 yards, use dimensional analysis to find the length of the race in miles. Ooh, but then it also gives you another hint. 1 mile is 1,760 yards.
So there's 1,000.
So make sure you always start with the given. What do they give you first? What's the value? 10 kilometers. Okay, guys. No, sorry. No. That's not. It's not 1,000. Sorry. That is 1.094. Sorry. That's 1 meter. I read it wrong myself. Is 1.094 here. Okay. So we're going to start off with 10 kilometers. 10 kilometers. We don't want kilometers. We want miles. So we're going to multiply it. But I'm going to get rid of kilometers. Wait a minute, I can't just get rid of kilometers, can I? Not in that respect. So I actually, because the only conversions I have is yards to miles and meters to yards. So I need to go from kilometers to meters first. So 1 kilometer is equal to how many meters? 1,000. So kilometers cancel out. Now I'm left with meters. Now I can go from meters to yards. 1 meter is how many yards again? 9.4 yards. I'm now out of meters. I am now in yards. And I know a conversion to get me to miles now. 1 mile is how many yards? So yards will cancel. Are you guys seeing how I cancel my units every time? And then all I'm doing, oh guys, I forgot to do something. I forgot to state that the first one is a fraction. Because now I know I'm taking 10 times 1,000 times 1.094 times 1. What does that end up on top? Isn't it that? I moved the decimal 4 times, right? Because that's multiples of 10. All of that is over 1 times 1 times 1 times 1760. Over 1760. Take your trusty calculator out if you need to. 10K, anybody who runs should know this. A 10K is 6.21 miles. Page 129, 9 through 33. Odds, please. Have a fantastic day.